All right, let's pull back the curtain on the secret to mass production. The process that creates pretty much everything you touch. It's called injection molding, and believe me, it is the hidden engine of our modern world. Let's get into it. Now, really, just stop and think about that for a second. How on earth do you make millions of phone cases or little toy bricks exactly the same, down to the tiniest detail? It seems like it should be impossible, right? But the solution, well, it's not complicated. It's just incredibly clever. See, here's the trick. The secret isn't about making a million perfect products one by one. It's about making one perfect template, a single master copy that you can use over and over and over again. And that template, that's the injection mold. So let's start right there, at the very heart of the process, the mold itself. It's so much more than just a piece of equipment. It's the template that actually makes modern mass production possible. So what is a mold, really? Well, at its core, it's a hollow metal cavity, an exact negative image of the part you want to create. You shoot hot liquid material into it, it fills up every nook and cranny, and just moments later, a solid, perfectly formed product pops out. It's a simple idea, but the engineering behind it is absolutely extraordinary. Honestly, this is the perfect way to picture it. It's like a super high-tech industrial strength waffle iron. You pour in the batter, you close the lid, and boom, a perfectly shaped waffle. An injection mold works on the exact same principle, just, with molten plastic, under extreme pressure, and on a massive, massive scale. So you've got this one perfect template. How does it crank out millions of parts? It all comes down to a super fast, repeatable process. Every single time the mold creates a part, it's called an injection cycle, or what people in the industry just call a shot. Let's break down exactly what happens in that one perfect shot. The whole cycle is like this perfectly choreographed four-step dance. First up, injection. Molten plastic gets blasted into the mold's main entry point, which is called the sprue. Second is forming. The plastic then rushes through these internal channels, called runners, filling up the mold's cavity. Third, solidification. The plastic cools down really fast and hardens into its final shape. And finally, ejection. The mold pops open, and a set of pins push the brand new part right out. Then the mold slams shut, ready for the next cycle, all within a matter of seconds. But hang on, where do these amazing tools even come from? Molds are incredible precision instruments, and creating one is this fascinating journey, taking an idea from just a digital design on a screen to a solid block of hardened steel. It all starts as a digital blueprint, a 3D model where every single detail is meticulously planned out. We're talking everything from the cavities that form the part to the gating that controls how the plastic flows in. This digital design is then run through tons of simulations to get that plastic flow just right. Once the digital version is absolutely flawless, a massive block of steel or aluminum is carved into the basic shape. Then, precision machines take over, carving out all the intricate final details. Finally, the whole thing is assembled, and it's time for its first trial run, its very first shot, to see if that perfect virtual design actually works in the real world. Now, during that creation process, one of the most critical decisions you have to make is what the mold is actually made of. And this isn't some small detail. This choice is going to directly impact the cost, the speed, and frankly, the overall success of your entire production run. You've basically got two main contenders, steel or aluminum. Think of steel as the marathon runner. It's incredibly durable, it can last for millions and millions of shots, but it's a bigger investment up front. Aluminum, on the other hand, is the sprinter. It's cheaper and way faster to make, but it's going to wear out a whole lot sooner. So the key here isn't just looking at the initial price tag. The smart way to do it is to calculate the cost per part. Yeah, a steel mold might seem expensive at first, but if you're going to produce millions of units, that big upfront cost, when it's spread out, can make each individual part way cheaper than if you'd used a less durable aluminum mold. Okay, so that covers single material products pretty well. But what about more complex things? Think of a toothbrush with a hard plastic handle and those soft rubbery grips. How are those made all in one go? That's where you get to the next level. An advanced tool called a 2K mold. It is engineered to inject two different materials in a single cycle. Now, these molds are definitely more expensive to create, but they can be an absolute game changer. By producing a finished, multi-material part in one shot, you eliminate entire assembly lines, which saves massive amounts of time and labor costs down the road. So after all that, you've got steel, aluminum, these complex 2K molds. You kind of have to ask, Which one is truly the best?
And the answer is, well, it's a trick question. There isn't a best one. The best mold is the one that's right for your specific project. It is never a one-size-fits-all solution.
And this is probably the most important thing to remember. There is no single perfect mold for everyone. So instead of looking for the best mold, engineers focus on finding the right mold. And what's right is totally determined by the product itself. The right choice really comes from answering a few key questions about your product. What's its shape and what does it do? How many do you need to make? 10,000 or 10 million? And how fast you need them? The answers to those questions will point you straight to the optimal solution. And that's really the core principle here. You don't just pick a mold off a shelf. You have to engineer it for a very specific task. The uniqueness of your product is what absolutely dictates the design of the mold that brings it to life. So I'll leave you with a final thought. We obsess over designing unique products, but shouldn't we put just as much thought into the unique manufacturing process that creates them? It's definitely something to think about.